Yeah, good day, my students all over the world. Your chemistry tutor is here again, Mr. Akpeji Honesty. That is my name. There is a question before us, homogeneous and heterogeneous catalysis. I'll be doing justice to this and you will quite appreciate what will be done here. So please, you are required to like this video, share the video, and subscribe to my YouTube channel. Okay? So we want to look briefly at homogeneous and heterogeneous catalysis. And before, let me give a background introduction. Before I will talk about each of these type of catalysis, actually, if you are to classify catalysis, okay, or you classify catalyst, you classify catalyst based on different mode. One of them is based on its physical state. If you are classifying catalyst based on its physical state, we have gas catalyst, liquid catalyst, solid catalyst. And you can also classify catalyst based on the substance from which the catalyst is made from. And on that note, the type of catalyst we have there is inorganic catalyst and organic catalyst. You can also classify catalyst based on the way catalyst works. So if it is based on the way catalyst works, we have two types called homogeneous and heterogeneous catalysis. So that is where we are now. Now, let me talk about homogeneous catalysis. So actually, homogeneous catalysis is defined as that the catalyst is in the same phase with the reactant. Okay, in homogeneous catalysis, the catalyst is always in the same phase with the reactant. For example, you have reactant A, okay, plus reactant B, okay, in gaseous phase or state to give you product D and product E. Okay, their state of matter is given, and if the catalyst to catalyze this reaction is catalyst C in gaseous state, you can see that C is the catalyst. So you can see in this case that this catalyst is in the same phase with the reactant. The reactants are in gaseous state, the catalyst is in gaseous state. So this type of catalyst is called homogeneous catalyst, and the process is called homogeneous catalysis. I hope you understand. I will be giving you some examples. Let me give you some examples of homogeneous catalysis. Okay. Let me talk about homogeneous as number one. Homogeneous catalysis in gas phase. So, homogeneous catalysis in gas phase. You have, that means in gas phase where the catalyst is a gas and the reactants are also in gas. So you have example is oxidation of sulfur 4 oxide, where in the production of sulfuric acid you have SO3 produced here. This is 2, this is 2 to balance the equation. So if this reaction is catalyzed by nitrogen 2 oxide, it is in a gaseous state, you can see. Okay, this is gaseous state, gaseous state, gaseous state. So you see now that the catalyst, nitrogen monoxide or nitrogen 2 oxide, is in the same phase with the reactant. This makes it an homogeneous catalyst. Another example is you have a vapor of ethanol, or acetaldehyde. Okay, this is a vapor of ethanol, a vapor of iodine, which is iodine vapor, okay, acting as a catalyst. I can put it here, I can leave it here. Remember, this nitrogen 2 oxide that is acting as a catalyst here can also come out here. okay, is to tell you that it is a catalyst because it is not consuming the reaction. Okay, it comes out with the product. Okay, so this is the catalyst here, iodine vapor to give rise to a methane gas plus carbon monoxide and hydrogen, I mean, iodine vapor. So this is a catalyst. That is why it's coming out here in the product. Okay, it's not used up in the reaction. Okay, so you can see that the catalyst, which is in gaseous or vapor state, is in the same state with the reactant. That makes it what? An homogeneous catalyst. So another example is homogeneous catalysis in solution phase. That means the catalyst is a solution or liquid and the reactants are also in liquid. Okay, an example under that is you have a cane sugar which is C12H22O11 in liquid form, and you hydrolysis of cane sugar which is under using water. You have the catalyst is a sulfuric acid to give you glucose C6H12O6 plus fructose C6H12O6. Then it will give back the sulfuric acid. So let me not put it, will bring back the sulfuric acid as the catalyst. So you can see this is actually glucose, this is fructose. Okay, this is a disaccharide, and cane sugar is a disaccharide. When you hydrolyze a disaccharide, it will give you two monosaccharides. These are two monosaccharide units. Okay, so this is an example of what now? An homogeneous catalyst in liquid phase, the same phase, state of matter with the reactant. Okay, so these catalysts are actually called homogeneous catalyst. Why? Because they are in the same phase with the reactant. So now, with what I have explained now, at the end of the reaction, the catalyst will be mixed with the reactant. This is gas. The catalyst is also a gas. It will be mixed with the reactant. At the end of this reaction, the catalyst will be mixed with this, will be mixed with the product. The catalyst will be mixed with the product. Okay, the catalyst too here, this one, it will come out as one of the product. It will be mixed with the product. So how do you now separate it? So you see that when you bring filter paper, okay, you fold the filter paper in your conic in your funnel, okay, glass funnel, and the filter paper is here. You see that if, let's use this liquid now, plus the catalyst that will come out with the product. If you pour everything here, you see that because these are in solution, if you pour it here, what you are going to get here will still be your glucose, fructose, and H2SO4. I don't know whether you get it. So this makes homogeneous catalyst very difficult to recover in their reaction. At the end of the reaction, it's actually difficult. Actually, that will take me to advantages and disadvantages of homogeneous catalysis. So for homogeneous catalyst, number one, it is possible to carry out reaction at milder condition. Okay, you can actually carry out the reaction at milder condition, meaning that it can be carried out at low temperature and pressure. Homogeneous catalyst, since the catalyst is mixed with the product, okay, that makes it to have higher activity. Number two, number three, it makes it to have higher selectivity, and you can actually study spectroscopic techniques on that. So it is easy for spectroscopic studies. Those are the advantages of homogeneous catalysis. But the disadvantages is that, as I have earlier told you, that it is difficult to separate. It is irrecoverable. So number one, the catalysts are difficult to separate from the product because they mix with the product. So that means that they are irrecoverable. You cannot recover the catalyst. Okay. Then number two, they have limited thermal stability. Okay, that is their advantages. So let me quickly go to heterogeneous catalysis. So for heterogeneous catalysis, the catalyst is in different phase with the reactant. If I have, I'm using lettering to explain that, okay, so that you understand very well. Another name for heterogeneous catalysis is called solid catalysis, okay? It's called solid catalysis. So if you have reactant A and B to give you product D, okay, and E, okay, in whatever state, let me just put gaseous state, okay, you can see that this catalyst is in different phase with the reactant. The catalyst is a solid, the reactants are gas. This makes this catalyst an heterogeneous catalyst, okay. Hete means different, homo means same. So in homogeneous catalysis, the catalyst is in different phase with the reactant. Okay, I hope you understand that. I want to give some example. Take as number one that heterogeneous catalysis, heterogeneous catalysis, okay, with gaseous reactant. So heterogeneous catalysis with gaseous reactant. You can see as example number 1A, we have nitrogen gas plus hydrogen gas to give you what? To give you ammonia. This is in Haber process in the industrial preparation of ammonia synthesis, the industrial preparation of ammonia. So you have this catalyst called finely divided ion. Okay, you can see that it is in solid phase while the reactants are in gaseous phase. This also in the contact process, industrial preparation of sulfuric acid, where you use vanadium pentoxide or platinum, they are both in solid, they are solid catalysts, while their reactants are in where? They are in gaseous state. Okay, you also have in the Ostwald process, we call this process Ostwald process, which describe the industrial preparation of nitric acid. Actually, there are three steps in this process, but one of the steps is very, very key. Okay, the Ostwald process is the continuation of Haber process. What you get from Haber process is ammonia. So if you further oxidize ammonia, okay, you are going to have, okay, nitrogen oxide and water. Okay, further oxidation of nitrogen oxide, okay, will give you nitrogen 4 oxide, and further oxidation of this product and this product as you have here will give you the nitric acid. But we are not interested in the second step and the third step. We are interested in the step that initiate the reaction, which is the key step. Okay, in this step you can see that the catalyst is in solid phase while the reactants are in gaseous phase. So this is an heterogeneous catalysis. I hope you do understand. So another example of heterogeneous catalysis is the heterogeneous catalysis with liquid reactant. That means using liquid as reactant. You have an example is the decomposition of hydrogen peroxide, okay, which takes place in the presence of platinum catalyst to give you water and oxygen gas. Okay, put two here, you put two here, you balance the equation. Okay, you can see that this is in liquid phase. This is liquid phase. Of course, this one will go as a gas. You can see that this catalyst is in solid phase, is in different phase with the reactant. So this it makes this an heterogeneous catalyst, but the process is called heterogeneous catalysis. Okay, where the catalyst is in different phase with the reactant. So another example I will give to you is the reaction between liquid benzene and ethanoic chloride, CH3COCl. Okay, liquid benzene and this is liquid, This is also liquid, okay, and it's catalyzed by aluminum chloride. And aluminum chloride is solid, it's even white, okay. It will produce C6H5CO CH3 plus HCl. Okay, this is also liquid. This is also liquid. You can see that the state of matter of the catalyst is in different phase with the reactant. So you can see the reaction produce liquid benzene with ethanol chloride produce this should be phenyl. This is a phenyl. This methyl phenyl methyl ketone. Okay, phenyl methyl ketone. Then plus hydrogen chloride formed. Of course, the solid catalyst will also come out. And if you see what is happening here, you can actually see, please quite understand what I'm explaining here now. You can see this product is liquid. This product is also is a gas. This one will be giving off. In the end, you have your liquid as a product, which is water, and your solid. Okay, if you have both of them as the product, it is easy. You can get the solid catalyst back by simple filtration. Okay, by simple filtration, you take your filter paper, you divide it into two, divide it into four, then you create it here. Then when you filter this, the combination of this and the catalyst form as the product. When you filter it now, what will come out? You are going to have your water here, because your water will be filtered out and you are going to have residue. Your residue, because it is solid, it will be what now? The platinum. What do? You now have your filter paper like this containing platinum solid catalyst. Okay, what do? You simply take it to an oven, okay, at a mild temperature, and you dry it. And when you dry the catalyst, you can reuse it again, even for this particular type of reaction. The same thing is peculiar to this. The same thing is peculiar to all solid catalysts. That takes me to advantages and disadvantages of heterogeneous catalyst. I believe you can even draft out the advantages yourself from my explanation. So you can have it now that the advantage of heterogeneous catalysis is that the catalyst is easy to separate, very easy to separate, and it has long catalytic life. Okay, because you can reuse it at different times. That means the catalytic life is long. Okay, you can also it can be reused. Those are the advantages, and the disadvantage is that it has limited activity, it has limited selectivity, and it is only effective at the surface. So if you want to understand what I mean by activity and selectivity, I already created a video that differentiates activity, specificity, and selectivity of a catalyst. So I will not be explaining that in this video. So you are required to check up the video on catalysis 2, either catalysis 2 or catalysis 3 or catalysis 1. Check up the video and you will see the difference between activity, selectivity, and specificity. In short, I created equations to explain these things for you, so that when you write it the way it is in the exam, no examiner can fail you, either in WAEC or in NECO or in undergraduate examination, or even you are writing A-level exam. These things are peculiar for you. A-level exam, this is how to put down your answer. Perhaps any exam you are writing in chemistry that has to do with this type of course, you are required to put down the right answer. So please, my student or anybody viewing this video anywhere in the world, please just press the subscribe button and also like the video, share the video to others so that they can have the same knowledge in chemistry. Thank you. I'm waiting for you to tap it now. Just tap it. Be fast, okay? Okay, are you not tapping it? Come on, do that, do that. Okay, thank you very much.